The objectives of today's lecture will enable you to understand what are organometallic compounds with reference to Grignard's reagent as an example. We are going to discuss the reactivity of Grignard's reagent, and after that we are going to study the reactions of Grignard's reagent with various chemical compounds. Students, let us start today's lecture with organometallic compounds. Organometallic compounds are those compounds in which the carbon atom is chemically bonded to a metal atom. Such compounds are called organometallic compounds. Now, one of the most important organometallic compounds is Grignard's reagent. Grignard's reagent is the name based on the scientist whose name was Grignard, in which he used magnesium as a metal to produce organometallic compounds. And that reagent is called Grignard's reagent. Now students, let us see how this Grignard's reagent is prepared. Magnesium metal is cut into small pieces and is added to a solution of alkyl halides or aryl halides in dry ether. Over here we are using ether as a solvent, but the term dry ether means that this ether should be moisture free, no water contents should be present. The reaction mixture is heated with an electric heater in a round bottom flask, and you can see that a condenser is attached to it so that the vapors that are being produced will be cooled down and fall back into the solution. And the other assemblies are attached to this apparatus in order to avoid the contact of moisture or oxygen. Why? Because students, this Grignard's reagent that is going to be produced is highly reactive, that its nature will be spoiled if it is exposed to oxygen or moisture. And we are preparing this reagent for other chemical purposes, but if it is going to react immediately after it is formed, then it will be of no use. Therefore, this whole assembly should be oxygen and moisture free. Look at the chemical equation. This is Rx, means alkyl halide or aryl halide. It is going to chemically react with magnesium when it is heated in the presence of dry ether as a solvent. It is going to give you RMgX. Over here, R can be an alkyl group or an aryl group, chemically bonded to magnesium and a halogen atom, chlorine or bromine. Now this RMgX is a general formula for Grignard's reagents. Students, alkyl bromides are generally used in the preparation of Grignard's reagent because of its intermediate reactivity. When alkyl halides are used, the solvent employed is mostly ether. And after the reaction have taken place, by evaporating the ether, the Grignard's reagent can be separated. But mostly we do not separate the Grignard's reagent after its preparation from ether. So it is used as ethereal layers. So students, what is the reason that we do not separate the Grignard's reagent from ether? Because if we have to separate ether by evaporation, we are going to open the container in which we have prepared. So the oxygen and moisture from the atmosphere might react with Grignard's reagent and it is going to affect its reactivity. That is why mostly we use it in the presence of ether, because ether is an inert solvent. It is not going to chemically react with Grignard's reagent. So it can be used in the presence of ether. Now students, let us try to understand that why this Grignard's reagent or organometallic compounds, they are very important laboratory reagents because of their reactivity. Now organometallic compounds are nucleophiles because of the partial negative charge on the carbon of the alkyl group. Now students, mostly you have seen that in organic chemistry we encounter a positive charge on the carbon atom. But in organometallic compounds, you will see that there is a negative charge on the carbon atom of the alkyl group. And why is it so? Because it is directly attached to a metal atom. For example, this is alkyl lithium. It is also an organometallic compound. Similarly, this is RMgX, which is Grignard's reagent. It is also an organometallic compound. carbon atom being more electronegative as compared to the metal atoms like magnesium and lithium. So that is why it is going to impart a negative charge on the carbon atom, because the metals are always electropositive. The alkyl group as a whole is going to bear a partial negative charge, and the organometallic compounds act as a source of nucleophiles. For example, you can see in this compound, this is methyl magnesium bromide. You can see the negative charge on this carbon atom because it is directly attached to an electropositive metal atom. Similarly, in methyl lithium, you can see that the carbon atom is having a partial negative charge because it is directly attached to lithium, and lithium is a metal. Now students, let us study the nucleophilic character of these organometallic compounds. The following reaction supports the nucleophilic character of organometallic compound. This is methyl magnesium bromide. If we are going to react it with water, now what is going to happen, that this methyl is going to act as a nucleophile and is going to abstract this proton or hydrogen from water. And this OH negative, the hydroxyl ion, is going to attach with magnesium, giving you methane. CH3 is going to attach another hydrogen, giving you methane, CH4, along with MgOH Br. So you can see that in this reaction, Grignard's reagent is going to act as a nucleophile. Let us study another example. This is ethyl magnesium bromide. When it is going to react with water, this carbon is going to attach with hydrogen of the water, giving you ethane. And this magnesium is going to attach with this hydroxyl ion, giving hydroxy magnesium bromide. Students, this chart over here is representing that Grignard's reagent is a very important chemical reagent. It is used for the interconversion of functional groups. If we are going to react Grignard's reagent with all of these chemical compounds, then they are going to give us functional group derivatives. That is why Grignard